All right, in lesson 8, we're going to be working on linear functions, and this should definitely feel like a review from some work that we did in Unit 3. Okay, activity 1. Read the instructions there on your own and try this one and start the video again when you're ready. So Diego was thinking smallest to largest. He was probably thinking slope. This first one has a negative slope, second one has a slope of 0, last one has a positive slope. Mai was thinking going from largest to smallest. She was probably thinking y-intercept. This one is bigger than the middle one, which is larger than the last one. Okay, in activity 2, we are revisiting proportional relationships. So this should be a review from stuff we've done before. First thing, Jada earns $7 per hour mowing her neighbor's lawns. What is going to be the independent variable? That's going to be the hours that she works. What is the variable that depends on it? Well, her earnings. How much she makes depends on how many hours she works. B, write an equation that represents this function. So it's going to be y equals 7x. That should feel familiar. Y is representing her earnings, and x is representing her hours. And now we're going to graph this. First, we're going to label the axes. Hours is going to go on the x, that's our independent. Earnings is going to go on the y-axis, that's our dependent variable. And we're going to label at least 2 points with input-output pairs. Well, first we have the origin, 0, 0. Next, hours and earnings, we could say 1, 7. If she works 1 hour, she will earn $7. Then we could keep going. We could do something similar. 2, 14. If she works 2 hours, she's going to earn $14. There you go. Okay, using the example we did in number 1, I want you to try number 2 on your own. It's very similar. Go ahead. Okay, to convert feet to yards, you multiply the number of feet by 1/3. That's going to be the most important thing in this one. And I'm actually going to skip to B right away and look at the equation that we would write. So it would be y equals 1/3 x. That's going to be 1/3 times our x. And in this case, the y is going to represent the yards. That's what we get after we multiply the number of feet, which is x, by 1/3. So then going back to A, the independent variable is going to be our feet, and our dependent variable is going to be the yards. The number of yards depends on the number of feet. Down here on the graph, feet is our independent variable, so that's going to be on our x-axis. Yards is our dependent, that's on our y-axis. And I drew a line with some points that would match my equation. For example, 3, 1. 3 times 1/3 is equal to 1. Or 6, 2. 6 times 1/3 is equal to 2. So it all represents the same function. Okay, activity 3 should feel familiar as well. We're talking about tanks of water. I want you to read the problem on your own and then try numbers 1 and 2 before you start the video again. For number 1, tank B starts out with more water because it states that tank B starts with 400 gallons, whereas in the equation for tank A, you can see it starts out with 200 gallons. In the equation for number 2, you're going to have B equals 400 minus 5t. It's subtracting right there because in the problem it tells us that it's decreasing at 5 gallons per minute. Number 3, tank A is filling because it is adding 8t, and it shows that in the equation. And tank B is draining because it is subtracting 5t. We see that in the equation, and in the problem it says it's decreasing. Okay, the second few questions, try numbers 4 and 5 on your own and start again when you're ready. Okay, in number 4, we know that tank C is draining out, and that's because of the subtracting 7t, so it's losing 7 gallons every minute. In D, it is draining out as well, and that's because the amount of water is decreasing as time goes on. And I want you to label these on your axes, amount of water and time. Time is your independent variable, and as time goes on, the amount of water is decreasing. Okay, in activity 4, we have another familiar situation where we're saving money. So I want you to go ahead, try numbers 1, 2, and 3, and then start again when you're ready. Okay, who started out with more money in their account, and explain how you know? They started out with the same amount. Elena and her equation, you can see right there is 60, and Noah's y-intercept is 60. That's his starting amount. Who is saving money at a faster rate? Explain how you know. And it's going to be Elena. And here's why. She's saving $8 a week. Noah, if we make a slope triangle to find his rate of change, rise of 10, run of 2, and that's going to be a slope of 10 over 2, or just 5. So his equation is going to be Noah equals 60 plus 5W, $5 per week. Number 3, how much will Noah save over the course of a year if he does not make any withdrawals? So over here, I used the equation that we wrote. I plugged in 52 for the number of weeks, and Noah at the end of that year would have $320. How long will it take Elena to save that much? Over here, I used the equation for Elena, plugged in 320 to be equal to her total amount saved over here, and then I'm solving for W, subtract 60 from both sides, divide both sides by 8, did some scratch work over here to divide by 8, and I got 32 and a half weeks, or we can't really have half a week here, so at 33 weeks, she will have the same. Okay, to wrap up lesson 8, you'll want to take some notes here. How can we tell if a linear function is increasing from an equation? Well, we're going to be adding on whatever number is being multiplied by x. And that's going to mean that it has a positive slope, and that's what we'll see on a graph if it is increasing. If it's decreasing, we would have a negative slope going downward. How can we tell from the graph if the initial value of the function is positive? Well, the initial value, we're looking at our y-intercept. If it's above the x-axis, it's positive. If it'd be down here, it'd be negative. How can I tell from the equation? Well, the number that we're adding on that just has a plain old number, no variable, if it's positive, our initial value is positive.